Since my time in quarantine, I've had a lot of opportunity to play fetch with my dog. I've noticed that my dog Micah can't run as fast as my roommate's dog Ryder. So since I have really nothing better to do, I've decided to see if I can breed a race of super fast German Shepherds. To do that, I'm going to take the fastest 10% of German Shepherds in my population and breed them together. I'm given two heritability numbers for my calculations. I have a broad sense, which is 0.85, and then my realized or narrow sense is given to me as 0.67. I'm going to be using the realized or narrow sense heritability number because I'm interested in the additive genetic effects. The mean of my parent population is going to be 18 miles per hour. My standard deviation is 4 miles per hour. To find the other variables that I need, I can use a table with standardized values. Since I'm going to breed the top 10% of my population, my proportion selected is 0.1, my selection intensity is 1.755, my standardized selection point is 1.282. Alright, so here is my graph, and all the calculations I'm about to do are going to tell me which numbers go with which part of the graph. The truncation point is the threshold for my selection. In this case, it's the number in miles per hour where I can say, okay, this dog runs fast enough to be in the top 10% of the population I want to breed. In order to calculate the truncation point, we take the initial population mean and add it to the standard deviation times the standardized selection point, which gives us 23.128. This value tells me to only breed dogs that can run around 23 miles per hour and faster. Next, using the selection intensity from the graph, multiplied by the standard deviation, I can find the selection differential, or the difference between the average speed of all German Shepherds in my population and the average speed of the top 10% of German Shepherds. So that gives me 7.02 miles per hour. To find the mean of the selected parents, I just need to move some numbers. Since we know the selection differential equals the mean of selected parents minus the mean of the original population, we can see that the selection differential plus the mean of the original population equals the mean of the selected parents. So that gives us 25.02. To find my response to selection, or how many miles per hour are gained from this breeding, I multiply my heritability by my selection differential. And remember, our heritability is 0.67. That gives us 4.7 miles per hour. To find the mean of my offspring, or the average speed of my new German Shepherd puppies, I just add the old average speed to the response to selection. That gives me around 22.7 miles per hour. However, my dogs can't get infinitely faster. The selection response for a particular characteristic declines as we go down generations. One reason for this is that the extreme types may not be healthy. If I'm breeding specifically for faster German Shepherds, I'm probably selecting for things like longer legs or bigger leg muscles. But there reaches a point where the legs are too long or the muscles too big. And if we were to go past that point, my dogs wouldn't be able to run properly.